Okay, so the lesson that we're learning today is called finding time. Finding time. And like I said a second ago, as far as like you seeing this on Friday's test, it won't be there. Okay, I'm not going to ask any of these finding time questions on it. So the questions that are going to be on the test over all of these formulas that we've been talking about the last couple days, they will be just the equations as far as how you've seen them the last couple of days. This is a little different. So the whole purpose of me doing this is because I think being able to go in this direction is important, personally, as far as applying these type of formulas to stuff that you might actually do or see, in real world situations. So I actually think this lesson is extremely valuable, even though it's not necessarily a standard that is taught in Algebra 2. I mean, it is a standard because it's what we've been doing, but it connects these equations that we've been doing to logarithms. Okay, let me explain. You've got your formula sheet, so there's no reason for us to fill this in. We're just going to jump right into the examples. And we're going to do all four of these, and then you can see your homeworks on the back. I would say be cautious about number one. It's got one little trick to it, and I'll refer to that in just a minute. But let's go through these four questions real quick. A, you invest $3,000 into an account that does 5% annual interest compounded continuously. And the question is asked, how long will it take for your money to double? So first thing I want you guys to think about is this. What equation has to be used in this problem? Yep, PE to the RT. How did you know? Compounded continuously. Okay? Here's the difference between this problem and how y'all did this yesterday. What question are we answering? How long? And how long is what variable? We don't know T. We're finding time. Okay, we're finding time. So every other variable has to be replaced with something, right? So take A, your final amount. What's my final amount in this problem? I don't see 6,000 anywhere in this question. How did you know the final amount is 6,000?
Double the initial.
Exactly. It's doubling the initial amount. So the initial amount was 3,000. Doubling that is 6,000. So A is 6,000. P is 3,000. E is E. And how do we write the rate? 0.05. We're finding time. We're solving a, what kind? We're solving an exponential equation. You see that? So solving an exponential equation means this. I am trying to get that exponent and its base, what? So what do I need to move to do that? How do I move the 3,000? You divide. What's 6,000 divided by 3,000? So 2 equals e to the 0.05 t. How do we say we solved an exponential equation when your base was e? We turned it into a natural logarithm, ln. See, ln understood base e of what? No. Remember, do the loop.
2. So 2.
Yep, the ln of 2 will equal 0.05 t. So what do I do to actually solve for t? You divide by 0.05. So I would say go to your calculator. You can go ahead and write ln of 2 and get the value. Or you could go ln of 2, close that parenthesis, divided by 0.05. ln of 2, close that parenthesis, divided by 0.05. What'd you get?
13.86.
So 13.86 years. Now listen, when we find time, generally we do more of an estimating thing. Like, about how long will it take you guys to double your amount? It'll take about, what would we say? It'll take about 14 years. Now, you guys can be specific and say 13.86, or you can say about 14 years because of the nature of what this problem is. I know that kind of flies in the face of what I've been saying about rounding lately, but we've been talking about real specific stuff like money, and now we're talking about time. If it takes 13.86 years, we'd say, it takes about 14 years. Okay? So sometimes in certain types of situations like this, it's okay to round. All right, let's go to the next question. In 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year. In what year did the cell phone subscribers equal 43,871? Okay, first, we got to pick a what? We got to pick an equation, right? There's one that's being used on this one. Now, what is your initial thought? Of all the ones we've talked about, what's your initial thought? Appreciation? Does everybody agree? Good, that's right, because think about it. Does it ever say anything about compounded? It doesn't say compounded anything. It doesn't say continuously compounded, but you know your money is what? Or you know it's actually doing what? It's going up. So that is appreciation, which is simply A equals P times 1 plus R to the T power. Y'all got it on your formula sheet, okay? You don't have to memorize that. It's right there. All we've got to do is fill in all the spots. So let's start with A. What's the total amount we want it to get to? Okay, equals. What's the P value? What did it start with? 285 times 1 plus, what's R? 0.75, right? 75%. 0.75, and that's to the T power. Now, here's what I want you guys to think about. We're trying to figure out what is, or how to get this exponent and its base alone. So what do we need to move away from it to do that? How? So go divide 43,871 by 285. Tell me what you get.
153.
I put 153.93. If you put 154, it's not going to make a big difference. Okay? So no worries there. Now inside here, what does 1 plus 0.75 equal? So we are left with 153.93 equals 1.75t. Now, just like the last problem, how do we solve an exponential equation? Rewrite it as a logarithm. Is this base e like the last problem? So I'm not going to use what? I'm not going to use ln. I'm going to use log. And I'm going to change the base to base what? 1.75. So it's log base 1.75 of 153.93, unless you rounded, and that will equal t. Brady, where do I go to type that in? Remember? You don't? Get your calculator and remember. Where do we go to type in any change of base? Alpha, window, number 5. You gotta keep that in your memory because it's on your test on Friday. So what is log base 1.75 of 153.93? Yeah, it's going to round up and it's going to say, hey, it's going to take about 9 years. Now, is that really answering the question?
No.
This was asked a little differently. How did it ask the question here? In what year? Well, it's 9 years from when? So the technical answer to this question is 1994. Now, if y'all did all that work and y'all put 9 years as your answer, you think I would mark it wrong? No, I'm not that guy. But the technical answer here is 1994. But I wouldn't, again, if y'all did all that work correctly, obviously I'm not going to hold that against you. You did what was, to me, what was important. Just be careful in the future to always answer the questions that's asked, because on the ACT, they sometimes get you with that. Okay? C, a car valued at $22,000 depreciates at a rate of 14% each year. How long will it take for the car to be worth half of its original value? So some important numbers here. How long? Half. So first, let's pick an equation. What's definitely being used here? Yeah, they straight up slapped you in the face with it. It's depreciation. P times 1 minus R to the T. It's in your formula sheet. Again, you don't have to memorize these. All right, now, let's fill in all the blanks. A, what's the amount this time? What is it that the question is asking that it becomes? Half of the original, half of 22,000. So 11,000 equals P, 22,000, times 1 minus 0.14 or 14 raised to the T. All right, Brady. I'm trying to get T and its base alone. What do I got to move?
22,000.
How? When it's multiplying, so 11,000 divided by 22,000 is 0.5. So 0.5 equals, what is 1 minus 0.14? 0.86 raised to the T power. And just like the last problem now, we're going to rewrite this as a logarithm. Are we going to use ln or log? Definitely, because it's not base e. So we're going to do log base 0.86. Remember, the base of your exponent, t, becomes the base of your log, and then you loop. Log base 0.86 of 0.5 equals t. So y'all are going to go to your calculator. Where are you typing it in, Marley? Where are you typing this in? Alpha window 5. Alpha window 5. Log base 0.86 of 0.5. Push equals. What'd y'all get? About 4.6. And I would say what else would be completely fine? It's about 5 years. Actually, see, that's the trick here. Is 0.6 actually 6 months? Because 6 months would be 0.5, because that's half of 12. So it'd be more.
1.4 months.
So let's just say it's about 5 years. Think about it. If someone said to you guys, how long do you think it'll take your car to be worth half its value? No one's going to be like, I think it'll take about 4.6 years. You're going to say, it'll take about 5 years. Right? Right?
Yeah, it was
Okay.
4 years, 6 months, and 2 weeks.
There you go. That's right. Okay. Man. Last one. A culture contains 35 bacteria that doubles every minute. How long will it take the culture to have 4,500 in it? So let's pick a formula. What word stood out to you to tell you what formula to work? Doubles. Don't we have a doubles formula? And it's actually talking about that's how it's changing. It's not asking you how long will it take your money to double. It's saying it doubles every minute. So you're using doubles, which is A equals P times 2 to the T. It's on your formula sheet. You don't have to memorize it. Okay? Now, from here. A. What's the amount we want it to become? 4,500. Equals. What's the original amount? 35. Times 2 to the T. Am I allowed to multiply 35 by 2? No, remember, we're trying to get that variable exponent and its base alone. So we do what? We divide by 35, which gives me 128.57 is what I got. Y'all check me, make sure I'm right. So once again, just like the last two problems, The base is not E, so we don't use ln, we use log. Base, what? 2 of equals. So one more time, you're going to go to alpha, window, number 5. And you're going to type in log base 2 of 128.57. And y'all got really close to 7, right? So it's about 7 what? 7 minutes. Look at the question. Again, if you just wrote 7 or if you wrote 7 years, because that's what we've been dealing with, I would be very forgiving. Just be careful, because the question says it's happening every minute. Now, your homework's the back, but I want to show you something real quick. Number 1 kind of has 2 ways you could think about it. Okay? The rest of them, I think, are really, really straightforward in the way they're written. This one's a little trickier because it says it's like a tournament's going on, and every round, half of the players are eliminated. So here's how you can actually think about this formula. You could either kind of equate it to doubling. When something doubled, like that last problem we did, what number do we have as the base of our exponent? 2. So we could kind of equate it to that, but instead of it being doubling, it's going half. So we would put what there? 0.5. You could think about it like that. Or you could think about it like this. It's depreciation. And half is what percent? 50%, right? And what's 50% as a decimal? 0.5. So depreciation, wouldn't you go 1 minus 0.5? Which ends up being what? 0.5. So in this problem, guys, you're going to use the equation A equals P, and then instead of doubling, it's going to be half to the T. So that's the only tricky one, yes. Yeah. So those 5 questions are your assignment. Y'all got over 10 minutes to probably at least get close to completing them. And I'm going to hand out the review. Is this review homework? No. If you want to get ahead, can you? Of course, right after school, our Google Classroom, there will be a video posted that has me going through this whole review, problem by problem. You don't have to watch it ever if you don't want. But am I going to teach the entire review tomorrow? No, I'm not. Call me selfish, but I'm going to take it easy tomorrow. It's been a long week. And it's just a review. But this is what you'll need to study to be prepared for your test on Friday.